Today we're going to look a little bit more into inverse trig. And like anything in math, we're always going to do the inner parentheses first. So we're going to do the same problem twice right now. I just would like to show you possibly two ways to do it, and whichever way feels more comfortable for you, you can use that. Not all of the problems can be done both ways, but some of them can. So the first problem obviously can be done both ways. We're going to look at the unit circle approach first. This method works really well if you're an expert on your unit circle. So just like anything else in math, we do the inner parentheses first. So first question is, what is the sine inverse of 1/2? And that answer is, sine inverse of 1/2 is pi over 6. And then, so that inner parentheses becomes pi over 6. So now the question is, what's the cosine of pi over 6? And the cosine of pi over 6 is √3/2. So if you're good at your unit circle, that is the quickest way to do that problem. However, you can do it using a diagram and drawing a triangle like we've done in the past. So same thing. First thing we're going to do is the inner parentheses first. So the way I can do that is I can say, okay, what two quadrants is sine inverse defined in? And that's quadrant 1 and quadrant 4. But this inner parentheses is telling me that the sine is positive 1/2, so therefore my angle must be in quadrant 1. So I draw a triangle in quadrant 1. The sine is opposite over hypotenuse. And then you do Pythagorean theorem to find the missing side. So you say 1 squared plus b squared equals 2 squared. So that gives me b squared is √3. Oh, sorry, b is √3. Let's erase that. B squared. B squared is 3. B is plus or minus √3. And remember, you have to check if it's plus or minus. Since this is on the positive x-axis, it's positive √3. Now that we have a picture of the angle that has a sine of 1/2, the question now becomes, what is the cosine of that angle? Well, the cosine of that angle is adjacent over hypotenuse. So you also get √3/2 if you do it that way. So that way is good if you don't really know your unit circle that well. Let's look at a couple more. Again, unit circle approach, sine inverse of negative √3/2. So the first thing you do is based on what you know about sine inverse. What is the sine inverse of negative √3/2? Well, that would be negative pi over 3. And then now that inner parentheses becomes negative pi over 3, so that your problem becomes the cosine of negative pi over 3, which is 1/2. If you wanted to draw a picture, so we'll look at the next one. Draw a picture. Again, we're going to do the inner parentheses first. So I'm going to draw a picture of the triangle. Sine inverse is defined in quadrant 1 and quadrant 4. But since the sine is negative, we know it's got to be in quadrant 4. So we make our triangle in quadrant 4. The sine is opposite over hypotenuse, so this is negative √3. Put a negative there. and the hypotenuse is 2. So, and then once again, you do Pythagorean theorem to find the missing side of your triangle. So you say a squared plus negative root 3 squared equals 2 squared. That gives me a squared is 1, so a is plus or minus 1. And I have to choose the plus or minus since it's on the positive x-axis. We're going to say that it's positive 1. Now, once we have a picture of that angle, and theta is always the angle in the corner, once I have a picture of that angle, now I look at the triangle and I answer the question. The question now becomes, what's the cosine of that angle? And the cosine is adjacent over hypotenuse, so you get 1/2. So 2 approaches to that same problem. Now let's go ahead and look at number 3. It says the secant of the tan inverse of 1/3. This is one where we cannot use the unit circle because there is no angle on our unit circle that we study that has a tangent of 1/3. So there is no tangent equal to 1/3. So in this case, we have to draw a picture. We have no choice. So remember, tan inverse is defined in quadrants 1 and 4, but since the tangent is positive 1/3, it must be in quadrant 1, and tangent is opposite over adjacent. And then you do Pythagorean theorem to find the hypotenuse. So you say 1 squared plus 3 squared equals c squared. C squared equals 10. So c is root 10. And remember, it's not plus or minus because your hypotenuse is never ever negative. So your hypotenuse is root 10. Now, once you've gotten a picture of the angle that has a tangent of 1/3, we now look for the secant of that angle. The secant is the reciprocal of the cosine. So if the cosine is adjacent over hypotenuse, the secant is hypotenuse over adjacent. And that is the answer. Okay, same thing with the next problem, 4a. Cosine inverse of root 3 over 3. Why can't I use the unit circle for that? Because there's no angle that has a cosine equal to root 3 over 3. So I have to draw a picture. Now remember, cosine inverse is defined in quadrants 1 and quadrant 2. But because the cosine is positive, it must be in quadrant 1. Your theta is the angle at the origin. And the cosine is adjacent over hypotenuse. Then we do Pythagorean theorem to find the missing side. So I say root 3 squared plus b squared equals 3 squared. So root 3 squared is 3 plus b squared equals 9. B squared equals 6. B equals plus or minus root 6. And again, I've got to choose the plus or minus. This is going to be positive root 6 because it's going up on the y-axis. And so now, therefore, once I have a picture of the angle, now I answer the question, what's the cotangent of this angle that I have a picture of? Well, tangent is opposite over adjacent. So cotangent would be adjacent over opposite. It would be root 3 over root 6, which reduces to root 1 over root 2. And then you have to rationalize it by multiplying top and bottom by root 2. So the answer is root 2 over 2. Okay, these next problems are a little bit different. In these types of problems, you have to use the unit circle. And the difference in these problems and the last is that in these problems, your inverse trig is on the outside. of the parenthesis, versus the ones we did up above, the inverse trig was on the inside. But this just forces you to know your unit circle. So once again, we do the inner parentheses first. That says, what is the cotangent of 2 pi over 3? So you answer that question first. The tangent of 2 pi over 3 is negative root 3. So the cotangent is negative root 3 over 3. So then my problem changes to the tan inverse of negative root 3 over 3, because I found that inner parenthesis to be negative root 3 over 3. And then the tan inverse of negative root 3 over 3 is negative pi over 6. Okay, last problem. Once again, I do the, not the last problem, next last problem. Once I do the inner parentheses first, so that first I evaluate what is the tangent of negative pi over 4, and that answer is negative 1. So my inner parentheses is negative 1. So now I answer the question, what's the cosine inverse of negative 1? And that answer is pi. Now last problem, inner parentheses first. What is the cosine of 5 pi over 6? Well, the cosine of 5 pi over 6 is negative root 3 over 2. So now I have the sine inverse, whoops, forgot my I, of negative root 3 over 2, because the inner parentheses negative root 3 over 2. So the sine inverse of negative root 3 over 2 would be negative pi over 3. Okay, so you guys can go ahead and try the classwork and the homework on this and see how you do.